Okay, hello everybody. Welcome to 5.2, verifying trigonometric identities. All right, so in the previous section we did a lot of work with trig identities, but a lot of it was just kind of unguided. We had to figure out what things simplify to, but it was good practice for us to just get used to identities again and knowing what they are, so we can use them to manipulate expressions, okay? Now, by the end of the last section, you guys are getting pretty good at doing it, where it started to become a lot fun, right? So now, in 5.2, when people say verifying, right, what they're trying to do is you're just trying to show that something is true, okay? So in order to do that, we just use the identities and show algebraically that one side is equal to the other, okay? That's all we're doing. It's kind of like a proof, right? A proof, you were given a starting point, an ending point. You just need to show how it goes from one to the other, okay? So that's pretty much what verifying trigonometric identities is. It's just their algebraic proofs involving trig identities, okay? So here are some guidelines from the textbook, okay? I took this strictly out of there. So you guys can kind of see what are some major keys that you can follow to help yourself verify these identities, okay? So we usually work with one side of the equation at a time, okay? It's usually the easiest way of approaching it. And again, the more complicated the side, the more kind of moves you have to make on that side to try to convert it to the other side. All right, so always kind of identifying the more difficult side to work with is usually what you want to do. All right, and then again, right, we did a lot of factoring. We added, squaring a binomial. All these algebraic ideas come into play here in number 2. So make sure that you know that you are able to factor, add, apply all these properties, multiply by the conjugate, all that good stuff can be applied. So those are all their other skills you have in your tool bag. All right. Look for opportunities to use the fundamental identities, right? So we always want to use them, because they'll just make our life very, very easy. And then here, notice that it says that sines and cosines pair up well, secants and tangents, and so do cosecants and cotangents, right? And if you notice, all of these are just members of the Pythagorean identities, right? So sine and cosine, sine squared plus cosine squared is 1, secant squared is equal to 1 plus tangent squared, and then cosecant squared is equal to 1 plus cotangent squared, right? So all those are Pythagorean identities, so they're just saying that they pair well because of the fact that you have those identities, okay? And then here it says, if the preceding guidelines do not help, try converting all the terms to sines and cosines, right? So sines and cosines are the easiest to work with. It might take so much more work to do, but converting everything to sines and cosines usually is the last resort you want to go with, but it's always the fail-safe, right? So you're always going to be able to get your answers if you convert everything to sines and cosines, okay? And then number 5 is just trying to give you some motivation, like always try something, right? So even if you don't get to what you want to get to, at least it may help you out with a different type of problem. So again, some of these do get very difficult, so you just got to keep fighting through it, trying different ways, trying different methods, and until you get to the result that they're looking for, right? So without further ado, let's go ahead and try to start one here. So again, I'm getting used to this whole online streaming stuff here. So please give me some I gotta erase this. All right, there we go. All right, so just give me some time here. All right, so first example here, let's start with, we want to verify that this identity is true. So let's go with secant squared theta minus 1 over secant squared theta is equal to sine squared theta. Okay, so when you're looking at this, you're trying to make one side equal to the other. Now, please try to avoid working with both sides. You want to work with one side only. So if you look at this problem here, which of the two is the more complicated side? I would think it's this side, right? Okay, this is just a single term on the right-hand side. That's not really that complicated. But on the left, we got much more going on, right? So let's kind of focus there and kind of see what we can get. Okay, so I see on the left-hand side here, I have secant squared theta minus 1, okay? So right away, I kind of know that that's a Pythagorean identity, right? So I know that 1 plus tangent squared theta is equal to secant squared theta. Okay, if I subtract 1 here, I know that tangent squared theta is equal to secant squared theta minus 1. Okay, so what I can do is I can actually substitute tangent squared theta here in the numerator. So I get tangent squared theta over secant squared theta. Okay, so I know that this simplifies here. Okay, so let's keep going down that road. Okay, so what's next here? We have tangent squared theta, I know is sine squared theta over cosine squared theta. And in my denominator, I know secant is just 1 over cosine squared theta. Now this is a complex fraction, so what should happen algebraically here is we cancel cosine squares. All right, so now we're just left with sine squared theta, just where we wanted to go, right? Once we show that, we check it off, okay, we reached our goal, there's your problem, okay? Now, obviously, there's other ways that we can kind of approach this. I do want to show you a nice other clever way if we did this one, okay? So here we have the secant squared theta minus 1 over secant squared. Okay, now if I split up this fraction algebraically, I get secant squared theta over secant squared theta minus 1 over secant squared theta. Okay, so what's secant squared divided by secant squared? Well, that's 1. And what is 1 over secant squared equal to? Isn't that cosine squared? Using the reciprocal identity. And 1 minus cosine squared I know is equal to sine squared theta. Okay, so again, another method to the madness. Like, you know, in the previous section, a lot of the answers were saying that you can have many different varying answers. Well, that's true because you can take so many different routes to manipulate these things, right? But now we have an end goal. We're trying to make it equal to sine squared. So both of these methods are valid. You may even have another method if you try to sit there and do this on your own, right? But these are 2 different ways you can approach it. So just know that some problems are only restricted to one way, whereas others have many, many different possibilities, okay? So you just got to keep trying, right? All right, so that's our first example. All right, so let's move on to a next one here. All right, so let's say I gave you sine squared theta plus cosine squared theta over cosine squared theta secant squared theta. Okay, so you want to show that this is equal to 1. Okay, that is equal to 1. So that's what we want to go ahead and show. All right, so I'm sure some of you are already chomping at the bit. I know you guys can see that sine squared theta plus cosine squared theta is in a numerator. We know that's equal to 1. Okay, so that's getting us very close to where we want to go. So I can replace that, right? So I have, okay, so we have sine squared theta plus cosine squared theta over cosine squared theta secant squared theta is equal to 1 over cosine squared theta secant squared theta. All right, so now let's kind of go forward here. What can I do to kind of continue this? Well, let's try to use a reciprocal function with secant. So I know 1 over cosine squared theta times 1 over cosine squared theta. Secant squared theta is 1 over cosine squared theta. What's going to happen here? Nice and lovely for us here. When you multiply that, you're going to get 1 over 1, which is equal to 1. There you go. Okay, there's your answer. Right, so this makes our life easy, and we get the answer just like how we like it. And there you go. All right, so again, there is another method to this. If you want to sit there and try it, you can. But this is one way that we can do it. Obviously, there isn't just a single way to do it. But as long as you don't break any of the rules of the identities, I think you're okay, and you can continue moving forward. Okay. So let's see. Now, if you feel confident in the first 2 we did, right, why don't you just pause the video as we're moving on and see if you can do them on your own before we even... Okay, that is terrible. Pause the video and see if if you can do it on your own, right? Because again, you guys just want to get better at doing it. Because again, you're going to be, you have a quiz on it, stuff like that. So just getting good and natural at it is kind of where you want to go. So let's see what happens as we do some of these other ones. Okay. All right. So here's one involving some fractions. All right. So 1 over 1 minus sine alpha plus 1 over 1 plus sine alpha equals 2 secant squared, that's not a C, that's a secant, secant squared alpha. Okay, so again, if you want to try it out now, all right, before I start the process. Just pause the video and see what you get, all right? But either way, so I notice automatically here that these are conjugates, right? And I need to have a common denominator. So what I'm going to do is I'm going to multiply 1 plus sine x on the left. So that's going to give me 1 minus sine squared in my denominator. Plus, and on the right, I'm going to multiply by 1 minus sine x. And I'm going to get 1 minus sine squared x. All right, so now my denominators are the same. Okay, so we can go ahead and move forward. So we're going to get 2 over 1 minus sine squared x. The reason why we get 2 is because, again, here the signs are going to cancel out because you're finding the sum, and those are opposite signs, right? So those are going to cancel. So then I get 2 over 1 plus sine squared. We know that 1 plus sine squared is equal to cosine squared x. Again, that's a Pythagorean one. And then that's just going to give me 2 secant squared x because I wrote x this entire time. These are all alphas. All right, so on and so forth. All right, so 2 secant squared alpha is your final answer. All right, and that's, again, the way you want to approach it, because since they're telling you to add, you're most likely going to want to add, right? If they're telling you to do it, just do it. It's probably going to help you out when you get there, okay? All right, next example. Okay, it's going to be a similar one to what we just did. All right, so let's see what we get for the next one. All right, so next example, we're going to have 1 over 1 minus cosine bravo, or beta, not bravo, over 1 plus cosine beta, I'm going to say bravo again, equals 2 cosecant squared beta. All right, so we just did one that's very similar to this. If you want to pause the video and try it out, you can. But without further ado, here we go. We get 1 plus cosine b over 1 minus cosine squared b plus 1 minus cosine beta over 1 minus cosine squared beta. Similar situation, we're adding here, and I noticed that my cosines are opposite signs, so they're going to cancel out. All right, so we're going to have 2 over 1 minus cosine squared beta, 2 over sine squared beta, which is equal to cosecant squared beta. All right, so there's your solution. Okay, again, you're just trying to find a common denominator. You're going to add them as normal, and then we know that this is a Pythagorean, so we're going to go ahead and convert that. Once we convert that, that's a quick reciprocal function, and there you go, there's your answer. Okay, so not much to it. Again, just being more familiar with the identities is definitely going to help you out. Once you feel comfortable with these identities, I encourage you guys to do as many problems as you possibly can. Okay. All right. Next example. So we have secant squared x minus 1 times sine squared x minus 1 is equal to negative sine squared x. Okay, so we want to go ahead and approach this one and see what we get as results. Now, there's definitely some kind of Pythagorean stuff going on here and here, so we kind of want to see what's happening with that. So I know 1 plus tangent squared theta is equal to secant squared theta, and I know that sine squared theta plus cosine squared theta is equal to 1, right? So if we take a look at this problem, okay, I can definitely see where we get this, right? If I solve for cosine squared theta, I get 1 minus sine squared theta. And notice that the signs are just off by -1, so then our answer is pretty much going to be negative cosine squared theta is equal to sine squared theta minus 1. So I know that that's going to be negative cosine squared theta. All right. Now the secant squared theta minus 1, that's quick, right? If I just subtract this 1 on the other side, I get tangent squared theta. So this is tangent squared theta. Okay, and this is going to be negative cosine squared theta. Okay, so now you can kind of see what we need to do here. Convert this into the quotient identities. So sine squared theta over cosine squared theta times negative cosine squared theta. What's going to happen with these cosines, people? Oh, I haven't used green. I don't want to use green. Yellow. All right, here we go. Cancel, cancel. That negative does not go away, though. Please do not forget that negative. Well, that's where we're going anyway. We're going to get negative sine squared theta. All right, and I keep using the wrong variable. Please do not do that. I keep doing that. Make sure that that says x, so negative sine squared x, because, you know, I keep intermixing the variables here, but algebraically, that's kind of what you need to do there. All right. Okay, let's do another. Again, pause the videos. If you want to test it yourself, if you want to challenge yourself, please do so. Again, you're only going to get better at it if you do that. And then if you get stuck, you can always just put the video on and see what I'm doing. So again, use that to your advantage since we now are online. All right, it's not like you can pause me in class or anything. All right, next one, here we go. So we get tangent squared x plus 1 times cosine squared x minus 1 is equal to negative tangent squared x. All right, so same thing as before. I know tangent squared x, that is going to be secant squared x, and I know that cosine squared x minus 1 is going to be negative sine squared x, right? Same idea with the Pythagorean identities. So if you need to kind of just look at those, you should look at those again. All right, so then this is going to be 1 over cosine squared x times negative sine squared x. All right, so that's just going to give me negative sine squared x over cosine squared x, and we know by definition that's going to give me, or the quotient identity really, negative tan squared x. And for the first time, I used the correct variable, so we are good and we are on track. Okay, so let's keep diving into some more of these different style of questions. All right, the next one we have here is the cosecant of x minus the sine of x is equal to the cosine of x cotangent of x. All right, lovely. Okay, these are good, and let me explain why these are good. All right, so we are going from, whoa, can we zoom out here? Like, what's happening? All right, so we're going from something that has addition and subtraction to something that has multiplication. So most likely we're going to have to find a way to combine these two. Okay, so what you want to do is, so cosecant is a reciprocal function, we're going to convert that. So we're going to get 1 minus sine x minus sine of x. Okay, now if I'm going to subtract these two to form a single term, because again, they're two separate terms, we're trying to go to something that has one term, if you notice here on the right. So we're going to add them together. Or subtract them in this case. So common denominator, you're going to get 1 over sine x minus sine squared x over sine x. When you combine them, that's going to give you 1 minus sine squared x over sine x. 1 minus sine squared x we know is going to be cosine squared x over sine x. Now if you look at our answer here, we have to find a way to make a cosine and a cotangent, right? So I know cosine squared x is the same thing as cosine x times cosine x and over sine x. So if we take a quick look, if I combine these two, I'm going to get my cotangent. and then my cosine is just going to be up top by itself, right? So you combine those two, use the quotient identities, so then we get cotangent x, cosine x, and we've reached our goal, people. There is your solution. All right, so again, another little clever trick. That's the first time we're seeing something like that. So again, just make note of all these little tricks that are occurring, because algebraically, that's how they're getting these results. And they're going to start to be more disguised as we go on deeper into the section. So, you know, just be aware that there's going to be many different ways to manipulate these moving forward. Okay, next one. Let's do tangent x plus cotangent x equals the secant x cosecant x. Again, similar situation, a sum that's going to be a product, so we have to convert these to fractions, add them, and see what we get, right? So we got tangent x plus cotangent x. If we convert those to fractions, we're going to have, you don't want to convert it, I mean, I guess you can convert it into 1 over cotan, or you convert them to sines and cosines. Either way, it's going to work well. So let's do sines and cosines this time around. So sine x over cosine x plus cosine x over sine x. So common denominator, you're going to have to multiply the left fraction by sine. So we're going to get sine squared x over sine x cosine x plus cosine squared x over sine x cosine x. Okay, in my numerator, if I add those two, that's nice. We get 1 over sine x, cosine x. And then notice that the reciprocal of sine is cosecant, and then the reciprocal of cosine is secant. So all you have to do is take the reciprocal of each, and we get or let's do it in the same order that they have it. Secant x, cosecant x. And there you go. There's your answer. All right. So again, just learning how to manipulate it in many different ways is good. But again, it makes your life so much easier if you know these identities. So again, knowing these identities is very, 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 very important. Okay, now if you notice, we only worked on the left-hand side up to now, right? Like every time they gave it to us, it was just the left-hand side, nothing much else to it. This is out of control. So now let's go ahead and look at the next problem. So here we're going to have secant y plus tangent y equals cosine x over 1 minus sine x. Now, or sine y. I keep changing these variables. Let's correct it here. All right, so working, I guess we can work with the left-hand side, but we could also work with the right-hand side. So either way, either one you want to do is kind of perfectly fine here. But let's try this one working strictly with the right-hand side, right? Let's try this side only here. So we're starting with cosine y over 1 minus sine y, okay? Now, we, I guess, can try to split this up in whatever way, but the only problem is you have 2 terms in your denominator here, so you don't want to really split up the fraction because that's not really going to be helpful. You're going to kind of be running in circles. So let's try by multiplying by the conjugate, okay? Samantha suggested this, in class the other day, and that's actually a very, very useful tool. Once you see 1 minus a term, because Pythagorean Pythagorean identities are so powerful, like it's great to always try to force a Pythagorean identity. So we're forcing one here. So if I multiply the top, I get cosine y plus cosine y sine y. And that's going to be over 1 minus sine squared y. Okay, so what do we get in this denominator now? We're going to get, let's write this numerator first. We're going to get cosine squared y. Okay, now again, pay attention to what we're trying to get to. We're trying to get to secant plus tangent y, right? That's our goal. So we still need to be on the path to getting there. Okay, so what we can do is we can now split this up as cosine y over cosine squared y plus cosine y sine y over cosine squared y. Okay, now notice, again, now I'm splitting it up because we now have a single term down here. Before we had two terms, it kind of made no sense to split up, but now that you have a single term, I mean, why not? It makes life so much easier. So 1 over cosine is what we're going to have here algebraically, plus here we're going to have sine y over cosine y. Now if you take a quick glance at where we need to go, which is all the way up here, okay, secant is the first term and tangent is the second term. So we pretty much got our answer here. So secant y plus tangent y. Okay, so there you go. There's your answer. You're done. Not much more you need to do there. All right, so I'm sure that one was one where we should probably do another because you are working with conjugates, okay? So again, identifying when to use a conjugate is always kind of important. So let's see what that looks like in this next example. Okay, so we have the cosecant of beta plus the cotangent of beta is equal to sine beta over 1 minus cosine beta. So yeah, let's work with this right-hand side. Okay, so I need to multiply by the conjugate. So 1 plus cosine beta, 1 plus cosine beta. We get sine beta plus sine beta cosine beta over 1 minus cosine squared beta. Okay, so we're going to get sine beta plus sine beta cosine beta over sine squared beta. Same thing, so this really feels like the same exact problem, just different terms. But here we go, we get sine beta over sine squared beta plus sine beta cosine beta over sine squared beta. Okay, so this is going to give me 1 over sine beta plus cosine beta over sine beta. And what do you know? We have our final result here of cosecant beta plus cotangent beta. Okay, so again, that's where we wanted to go originally, up here. And that's where we got. Okay, so again, kind of working with that is kind of where you wanted to go. All right. Okay, we are almost done. Okay, few examples. Some of these are going to get a little bit more difficult, a little bit more challenging, but you know, we'll see what we get when we start to do them. All right, so in the first few examples, everything has been working with one-sided equation, converting to the form given on the other side. All right, so sometimes, not always, it's actually very practical if you work on both sides separately, so that way you can get a common form on each side, right? So again, this is when you actually have two very complex sides, right? So let's try to take a look at an example. So here, let's say we have cotangent square theta over 1 plus cosecant square theta. And that's going to be equal to 1 minus sine theta over sine theta. All right, so obviously two very, very complex sides. Trying to think if we can maybe do this a certain way. Yeah, it's going to be difficult because there's, you know, a lot going on in that aspect, right? So let's just try to approach this in, oh, actually, my apologies. This shouldn't be squared because then that makes it easier. It's actually this. Okay, so what we can do, okay, is I can work with this. Let's work with the left side first. Okay, so I have cotangent square theta over 1 plus cosecant theta. Using the trig identities, I know that this is cosecant square theta minus 1 over 1 plus cosecant theta. I can factor this as cosecant theta plus 1 and cosecant theta minus 1 over 1 plus cosecant theta. Now if you notice algebraically, these two are equivalent. Cancel, cancel. So now we are left with the cosecant theta minus 1. Okay, so now that's something that we can kind of work with. That's nice to work with. But again, we're not where we want to go. We want to show that both sides are equal, right? So here's the right side one. All right, so now I believe our right side was 1 minus sine theta over sine theta. Okay, so working right side on this one, notice that I can split this up as 1 over sine theta minus sine theta over sine theta. And that's just going to give me what we need, cosecant theta minus 1. Okay, there you go. So now both of these are equal. And you didn't break any rules on both sides, so therefore you found a common ground where they can both reach. And you got there, okay? Now, I do want you guys to try something here. I want you to try working with one of these two sides and only using one of these two sides to get the other side, right? If you think you can do that, take a picture, upload it to me. I'll give you extra credit for that, right? So if you can do this here as an extra credit opportunity, okay, if you could just work with one side and prove that to be true, I'll give you guys some extra credit on that one because that was kind of fun to do if you did do it with just one side. Okay. All right, and just to close off this section here, again, this is going to be a long section for you guys to do in terms of your own work because we're going to do a ton of these because, again, we got to be very proficient at them. So you're going to see so many different cases. So you're going to have to reference this video a bunch of times. You know, we're going to use some kind of procedure that we normally use in calculus to help verify some identities, right? So here we have tan cube. Sorry, I can't go that high. All right, so here we go. Tan cubed of x is equal to tan of x secant squared x minus the tangent of x. Okay. All right, so we're going to start with actually tangent cube of x. And I'm going to split that up into the tangent of x times the tangent squared of x. Okay, now why would I want to do that? Well, notice that I have tangents here in the right side of the problem, but I also have the secant, right? And notice that it's secant squared. Now I know that secant squared goes nicely with tangent squared because those are like some Pythagorean identities. So tangent x times, if I substitute secant, this is going to be secant squared x minus 1 using the Pythagorean identity. So if you multiply, you get tangent squared x, secant squared x, minus a tangent x when you distribute tangent squared x, right? And then that's what you wanted to get to. All right, so let's look at some other different cases where we're breaking down these higher powers of sine and cosine, and we're breaking them down using, again, that very powerful power of 2, because the power of 2 is great when we work with the Pythagorean identities. All right, so let's look at another case here. All right, so cosine cubed x sine to the 4th x. Okay, so this is going to be equal to the sine to the 4th of x minus sine to the 6th of x times the cosine of x. All right, so coming up with this one should be interesting. All right, so I know that since this is a cosine of power 3, that's going to be the one that I want to break down into a power of 2. So let's do that here. So we get cosine squared x times cosine x times the sine of the sine to the fourth of x. Okay. All right, so then I know that cosine squared x is equal to 1 minus cosine, 1 minus sine, not cosine, where we already have cosine. Cosine x sine to the fourth x, okay? All right, now notice that we're just comparing the top one to the bottom one here. We have the cosine here already, right? So if I multiply the sine to the fourth over here, what's going to happen? We're going to get what we need, and that's going to be our final answer. So we're going to get sine to the fourth of x minus sine to the sixth of x, okay, times the cosine of x, and again, final answer. All right. So again, you're taking, some of these higher power ones, breaking them down into these Pythagorean ones, so you can kind of manipulate it into the form that you actually want. Okay. So again, hopefully this video helps. Again, like I said before, that understanding how to manipulate these is very important. And in all reality, it's very important now because, it's the majority of the section. But there's a few questions in calculus that you'll get from time to time where you're going to have to do this. So it's very important that you guys kind of know how to approach manipulating these expressions, right? So just a heads up looking forward, you're going to be working on this for at least 3 days because I'm going to break it up into 3 different parts. Again, any questions you guys have, please let me know in Google Classroom or shoot me an email. Okay, I try to do my best to help you. I will post solutions once all homework has been collected so you guys can kind of correct your answers. And then expect the quiz after this section. Okay, so that's where we're moving to, we're moving forward to now. So again, try to get comfortable with these identities, right? If you don't want to use me as your only resource, there's plenty of videos on YouTube that you can watch to kind of build your repertoire. But everybody's going to kind of say the same thing. You get better with experience, so just do as many problems as you can and see where it goes. All right, so again, thank you for watching this video. Make sure to like and comment below, or subscribe to my channel. All right, later guys.